Hi there, we are looking at trigonometry revision for grade 12, and this question paper, these questions are coming from the Exemplar 2014. The first question says, given that sine alpha is equal to -4/5 and alpha is between 90 degrees and 270 degrees, without using a calculator, determine the value of each of the following in its simplest form. So we have sine negative alpha, cos alpha, and sine alpha minus 45. How do we determine the value of each of the following? Whenever you meet a question like this, you should make use of a diagram. Sometimes the question actually says with the use of a diagram, but in this case, the question did not mention anything about the diagram, but you should know. For you to be able to answer this question, you need to draw the diagram. We have two clues here which are going to tell us exactly where to draw the diagram. Remember, we have got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And from quadrant 1, we start from 0 degrees, then this is 90 degrees, this is 180 degrees, and this is 270 degrees, and it comes back to this one to complete one revolution, that is 360 degrees. Now, we are told that our alpha is between 90 degrees and 270. So it's between this and this area. That is quadrant 2 and quadrant 3. But where exactly should we draw the diagram? We have a negative here. Sine alpha is negative. We know that our cast diagram, sine is positive here and sine is negative in the third quadrant. So that's how we determine where to draw this diagram. And we have the diagram now. We are told that sine alpha is equal to -4/5. So sine alpha is opposite over hypotenuse. So it means this is our opposite and this is our hypotenuse. Our opposite is here, that's -4. Our hypotenuse is +5. And when you have these two sides, you should determine the third side. And this is the first set of the Pythagorean triads. So this is a 3 according to Pythagoras theorem, and it's on the negative side, so it's -3. Now, sine negative alpha can be written as negative sine alpha, and this should be equal to sine alpha we're given here. So this is a negative plus another -4/5, which is equal to +4/5. Remember, a double negative gives you a positive. And then cos alpha, remember cos is adjacent over hypotenuse. Here is our adjacent, is -3. So here is -3/5. And the third one, sine alpha minus 45. This is a compound angle. You remember compound angle formula? Let's write it here. This is expanded as sine alpha times cos 45 minus cos alpha times sine 45. We have alpha, we have 45. Now, sine alpha and cos alpha, we get them from our diagram. But cos 45 and sine 45, these are special angles. 45 is a special angle. Do you remember your special angles? You are supposed to know them by head. If you do not know them, you need to draw that small triangle. This is isosceles triangle with adjacent 1, opposite 1. This is 45 degrees and 45 degrees according to Pythagoras theorem. This is root 2. Now from this diagram, from our diagram, our sine alpha, we saw that sine alpha is negative 4 over 5 multiplied by cos alpha. We can get it from this diagram. It's adjacent of hypotenuse, that's 1 over root 2, and this is minus cos alpha. Our cos alpha, we got it here, is negative 3 over 5 multiplied by sine 45 is opposite over hypotenuse, that's 1 over root 2. You should notice that these are equal. Cos 45 is equal to sine 45, co-functions. 45 plus 45, that's 90. So this should be equal to negative, this multiplied by that is negative 4 over 5 root 2. Negative and the negative gives us a positive. 1 times 3 is 3 over 5 root 2. And this should be equal to, this is positive, this is negative. So we have a negative 1 over 5 root 2. That's the first question. All right. Continuing the second question. Consider the identity 8 sine 180 degrees minus x multiplied by cos x minus 360 degrees all over sine x squared minus sine 90 plus x in bracket all squared is equal to negative 4 tan 2x. This is an identity. Remember, when you are dealing with identities, you need to simplify or deal with one of the two sides until it is equal to the other side, or you have to simplify both sides sometimes. So with this one, let's start with the left hand side. The left hand side is equal to this. This is 8 multiplied by sine 180 minus x. This is a reduction formula. It's in the second quadrant and sine is positive in the second quadrant. So this is sine x multiplied by cos x minus 360. I want you to remember that 360 is a revolution. So if you add 360 or subtract 360 from an angle, it does not change position. It remains at the same position. So with that, we can say cos x minus 360 is equal to cos x, because if we add 360 to this angle, it remains the same. So we have cos x all over sine x squared minus, now this one, sine 90 plus x squared. This is co-function or co-ratio. We find it in the second quadrant. 90 plus x is in the second quadrant, and sine in the second quadrant is positive. So this one becomes cos x squared. It becomes cos x squared. And this is going to be equal to what? I'm seeing expansions here. Expansion of the double angle of sine and also cos. The expansion of sine 2x, remember, it's sine 2x is equal to 2 sine x and cos x, right? So we can remove 4 from this 8 and we have 4 and then 2 sine x cos x all over the expansion of cos. We can use the expansion of cos here, but the expansion of cos 2x is equal to, it's cos x squared minus sine x squared. Now, how do we fit it here? We have cos x squared minus sine x squared, but here there is sine x squared minus cos x squared. We need to factor out -1. If we factor out -1 here, we are going to be left with -1 bracket negative sine x squared plus cos x squared, right? This is negative, so we can take it to the left side. So we are left with cos x squared minus sine x squared. Now it's easier. This is equal to, this becomes 2, this becomes 4, is 4 sine 2x all over, there is a -1, so it's -1 cos 2x, and this is equal to -4 sine this divided by cos this. Remember, it is tan 2x, and this is equal to the right hand side. We have proved our identity. And the next question, for which values of x in the interval 0 degrees to 180 will the identity be defined? For which values of x will this identity be defined? Usually when you are looking for values for which an identity is defined, you look at the denominator. You know we cannot divide by 0, right? So this identity here will be undefined when cos 2x is equal to 0. So we solve this equation. How do you solve this equation? Let's look for the reference angle. 2x is equal to cos 0, and this is equal to this is equal to 90 degrees. So we are saying 2x is equal to 90 degrees. When 2x is equal to 90 degrees, we divide both sides by 2. So our x is equal to 45 degrees. Our x is equal to 45 degrees. Remember, the question says in the interval 0, when x is between 0 and 180, this is the first quadrant and the second quadrant. So x is equal to 45 degrees in the first quadrant, and in the second quadrant, remember reduction formula is 180 minus 45 degrees, and this is equal to 135 degrees. So the values of x for which this identity is undefined, it's when x is equal to 45 and when x is equal to 135 degrees. And then the next question, which happens to be the last question in this section, it's saying determine the general solution of cos 2 theta plus 4 sine theta squared minus 5 sine theta minus 4 is equal to 0. Let's determine the general solution. Let's determine the general solution of this one. All right. Our first step here is to deal with this cos 2 theta. I want you to notice that we have got sine, we have sine, and then we have cos. And the expansion of cos 2 theta, you know, it has 3 different expansions, and one of them has got sine. So for uniformity, we replace this with the expansion that has sine. So this one becomes 1 minus 2 sine theta squared, and then plus 4 sine theta squared minus 5 sine theta minus 4 is equal to 0. There's something that we can simplify here. 2 sine theta squared and 4 sine theta squared. Put these together, there's a negative here. So we have negative 2 plus 4. We get a 2 sine theta squared. And then we have minus 5 sine theta. There's a negative 4 and a positive 1. So that's negative 3 is equal to 0. I want you to notice that we have 2 sine theta squared minus 5 sine theta minus 3, or we can say minus 3 sine theta to the power of 0 to the power of 1 to the power of 2. This is now a quadratic equation which we can write as 2x squared minus 5x minus 3 is equal to 0. Now we need to factorize this quadratic equation. We can factorize it, create our 2 brackets is equal to 0. So this is going to be 2x, and this is x plus 1 minus 3. So we can say here, therefore 2 sine theta. Remember, sine theta, we replaced it with an x, right? So here 2x, we can write it as 2 sine theta plus 1 is equal to 0, or sine theta minus 3 is equal to 0. Let's simplify here. We have sine theta is equal to negative 1 over 2, or sine theta is equal to 3. You should be able to notice that this one has no solution, but this one does have a solution. Our theta there, look for the reference angle. Theta is equal to arc sine negative 1 over 2, and this is equal to 30 degrees, and our sine is negative there. Our sine is negative, and we know sine is negative in the 3rd and the 4th quadrant, right? Sine is negative in the 3rd and the 4th quadrant. So we are saying in the third quadrant, using our reference angle, we are saying 180 degrees plus 180 degrees plus 30 degrees plus 360k, right? Or this is the third quadrant. The fourth quadrant is 360 degrees minus 30 degrees plus 360k. Simplify this. Our theta then is equal to, this is 210 degrees plus 360k, or 330 degrees plus 360k, and this k is an element of Z. You should never forget to mention this one. That's our trigonometry. Enjoy.